Computer Science, Syllabus Statement 1.3.3h. Describe the principles of operation of microphones and describe how they are applied to real-life scenarios. So, a microphone is a device which can input sound into another device. I'm using one right now, and I'm pretty sure most people have used them as well. So, like when chatting with their friends on their phones and going on Skype and whatever, microphones are used for that. So, microphone kind of looks like this, but it can also be like holes on a computer. Yeah. So microphones can be used for doing a voiceover in a presentation, speech recognition, voice recognition, and enabling disabled people to communicate with their computers. But the two major uses that we're going to look at are speech recognition and voice recognition. Now, voice recognition is a little bit simpler, so we'll start with that. But before that, we should look at the principles of operation of microphones. So when a microphone detects sounds, a diaphragm vibrates, producing an electrical signal. This signal is transmitted to a sound card and is converted into digital data and is then stored in the computer. Simple. Now, voice recognition. What happens is the user's voice is detected and then converted into a digital wave pattern. Now, as we'll see soon, when we're looking at sensors, we'll see that we know that computers can't actually read like physical data. It's going to have to be converted in some way. So we'll cover all that in sensors. So once you watch that video, it'll make more sense. But for now, let's just stick with this stuff. So software will then compare this wave pattern with stored wave patterns to see if they match. If they match, the person has correctly been identified. Yay. Only certain words can be used in this, usually, as most systems are limited to only recognize keywords or phrases. This technology is good for security. Now, what we mean by it's good for security is, well, actually it's pretty obvious, but like say you want to protect a room which had secret files, so only you were allowed in there. What you could do is set up voice recognition software which will allow access if it senses your voice. If it's not your voice, then they won't allow access. That's pretty much how it works. Speech recognition is a little bit different though. In speech recognition, software tries to recognize the words spoken by the user as opposed to the user's voice. The spoken words or phrases can be displayed, input into a word processor, or used in other applications. So this is how it works. When a sound is inputted, the sound card in the device will convert the sound into digital data. The software will take the digital data and break it up into phonemes. Now, what a phoneme is it's how do I explain this? It's kind of like the sounds in words, like the individual elements of the sounds in words. So like hello would be h, e, o, u. So those would be the phonemes, the individual sounds in. Anyway, these phonemes will be compared with words in the built-in dictionary, if there is one. The word spoken will then be suggested by the software in the application being run, and hopefully it's reliable and will output whatever has been spoken. The concept of speech recognition is far more complex than that example. Now, we looked at keyboards in the other video, and I talked about how keyboards, like maybe I've got a jar of nuts here. Anyway, keyboards like they're quite slow at inputting data, but it may be the easiest. Now, this is why. Speech recognition can be quite hard to use. Like, you could say something and the computer could misinterpret it totally. If you've ever spoken to Siri or Cortana, like, you may notice that some words that you say may not be recognized or like misinterpreted. So like, well, we'll look at an example now. The reason for this is the software must take into account different dialects and accents when trying to recognize what has been spoken. Now, this is pretty important because people around the world have different accents. It's like the Indian accent, the Russian accent, the I don't know, the Asian accent. Yeah. Anyway, so yeah, it's pretty like it's pretty complex for the software having to take into account all of this. So let's look at an example. So the phrases recognize speech and wreck a nice beach sound similar, kinda. But if the software breaks these up into phonemes, they will be very similar. So recognize speech something, and blah. So speech recognition can be used in cars. Commands such as turn on GPS and windows down will turn on the GPS and roll the windows down. So hopefully you have an understanding of how microphones work, and two of its major uses. And hopefully this will be on the exam, because I wouldn't want to waste my time doing this. But yeah, thanks for watching, and as always, see you guys when I see you guys, and yep. Computer Science Syllabus Statement 1.3.3i. Describe the principles of operation of touchscreens and describe how they are applied to real-life scenarios. So, touchscreens are basically devices which allow user to interact by touching areas on a screen. So, most of your phones may be touchscreen. So that's an example of a touchscreen device. So I have some pictures here. So we're going to be looking at 3 different touchscreen technologies: capacitive, infrared, and resistive. And there are benefits and drawbacks to each of them. So yeah, we'll be looking at principles of operation of each system, the benefits and the drawbacks. So let's get started. So just a little introduction. Touchscreens are very common, and they're simple to use as they only require the user to touch the screen, which everyone can do because we use our hands in everyday life. So, you know. And as said, there are 3 major types of touchscreen. The first one is capacitive. So we have a description, advantages, and disadvantages. So, capacitive touchscreen device is made up of multiple layers of glass, which act like a capacitor, creating electric fields between them. The electric current changes when the glass is touched, and the coordinates where it was touched is determined by a microprocessor. So, examples of capacitive devices include like Apple iPhones and Samsung Galaxies. The advantages of capacitive devices is medium cost, good screen visibility in sunlight. There's multi-touch feature. You may notice that some of your smartphones you can multi-touch. And the screen is quite durable. Quite a large impact to break, but don't try it, because I have friends who have broken screens. The only real disadvantage of capacitive is allows only the use of bare fingers and sometimes a stylus for input. Now, this might be considered an advantage, actually, because, well, you know, what else are you going to touch the screen with? Yeah, so it's not like you're... And also, if it allows fingers only, then you could keep it in your pocket without having to worry about, you know, your pants having to touch the screen, which is quite annoying. But yeah, it's considered a disadvantage because you might want to touch the screen with some other stuff if need be. So a capacitive touchscreen device kind of looks like this, rather. So there's the microprocessor, there's the screen, and electrostatic field caused by touching the screen, and coordinates are fed back. It's kind of like this. So there are 2 different types of infrared technology. There's heat sensitive and optical. So we'll look at both of these here. So both systems, both heat and optical, use glass as the screen. Heat sensitive uses a warm object as input, and the optical system uses an array of sensors, kind of like an invisible grid, and the point of contact is determined based on the grid coordinate touched. So examples of infrared devices include the Samsung U600 and the Samsung SGHE 900. Yeah, I did some research. Yeah. Advantages are multi-touch capability is permitted on both systems. The screen is quite durable, and the optical infrared system allows the use of bare fingers, gloved fingers, or stylus for input. I guess it's one of the disadvantages of capacitive is if you have gloves on, you can't really use the phone. But infrared is quite expensive, and they only have fair screen visibility in strong sunlight, so it's kind of annoying how, yeah. And the heat-sensitive system allows only the use of bare fingers. Now, there's also one other thing. With the heat-sensitive system, if you're using a heat-sensitive device in cold weather, your fingers are cold, then it's not going to work if you try to touch your screen. So that's why heat-sensitive systems aren't really common. So the optical system kind of looks like this, if you were wondering. So the grids here, and yeah. Our final system or technology is resistive. So resistive phones have an upper layer made of polyester and a bottom layer made of glass. When the top layer is touched, it completes a circuit with the bottom layer. The signals are then sent to the microprocessor, which calculates the coordinates where the screen was touched. Now, examples of resistive phones are the LG Optimus and the Nokia N900. Again, research those. Advantages of resistive include it's quite inexpensive, allows the use of bare fingers, gloved fingers, or stylus for input. And of course the disadvantages, there are always disadvantages. Poor screen visibility in strong sunlight. There is no multi-touch capability, and there's only fair screen durability. So the screen tends to be vulnerable to scratches and can wear out after some time. So if you're wondering what it kind of looks like, here's the top layer, here's the bottom layer, and when touched it completes a circuit, and the microprocessor or controller determines the coordinates from that. Computer Science Syllabus Statement 1.3.3J, and this is about interactive whiteboards. Now this is the last of the input devices that we have to cover besides sensors, but sensors is kind of a whole different thing by itself. Anyway, an interactive whiteboard is a device which can display computer images on a whiteboard using a projector. Now your school may have interactive whiteboards, such as the smartboard here. So we're going to be describing how they are used and how the advantages. So they allow the user to write or draw on it, but unlike a regular whiteboard, these writings or drawings can then be stored in electronic form on the computer to be used for later. And this is handy because if you use a regular whiteboard, you draw stuff, you might have to save it, you might have to take a picture and then store it on your computer, but with an interactive whiteboard you can just save it on your computer. It's quite handy. And this can be helpful in meetings or classes in school. For example, a plant cell is displayed on the whiteboard in a biology lesson. It's possible for students to label the parts of the cell on the whiteboard and have the annotations saved on the computer for the next lesson. So here we've got a plant cell. I sort of drew this, kind of looks really weird. So we have the cytoplasm, cell wall, the vacuole, cell membrane, chloroplasts, and nucleus, and you can annotate this, and this whole thing can be saved for later use on the computer, so that in the next lesson when we come back to learning about plant cells, then we don't have to rewrite this. We can save whatever's been done here. So it's pretty much how an interactive whiteboard works. It's also possible to interact with the interactive whiteboards using our fingers on the surface. And doing this, people can do on the whiteboards what they can do on the computer, such as browsing the internet or playing a game. And since a whiteboard is being used and it's quite big, many people can watch and get involved. And this is whole, yeah, it's another advantage of them. Yeah.